Hello everyone. Good morning, and respected authors and invited guests. I welcome you all to the technical session 8E. Myself, Gayatri Burguda, and I'm going to be the moderator for today. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you all to the 10th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being held through Zoom from 19th to 21st January. I hope you all will enjoy the knowledgeable session. And in this session, we'll be having 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. Upon 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with me throughout the session till the closing remarks. If you have any kind of query or doubt or update, you can directly text me in the chat box. And just before we start the session, I would like to introduce you all to today's session chair. Dr. Ramesh Chandra Punia is a professor in the Department of Computer Science at Christ Deemed to be University, Delhi, India. His research interests include sustainable technologies, cyber physical systems, path planning, and collision avoidance in artificial intelligence and intelligent algorithms for autonomous systems, with active involvement in teaching, research, and academic advancement. Sir, would you like to address the participants?
Yes, ma'am. Please go ahead.
Yeah. Okay, I would like to call upon our first presenter now. Our first presenter for today is Bhadra S. Pillai for the paper titled Advances in Artificial Intelligence for Crop Disease Detection, a review. Over to you, ma'am. We'll wait for a minute until she responds, or else we can move to our second presentation. Okay, since the first presenter isn't responding, Himang sir, would you like to present?
Yes, sure, I can.
Yes, so you can start sharing the screen.
Sure, just give me a moment. All right, so let me share my screen.
Yes, sir.
I think you have to allow me to share, or you have to stop.
So can you
Sure,
can you try once again? Yes, sir. The screen is visible. You may start.
Perfect. Thank you so much. One second. Okay, are you able to see my screen?
Yes, sir. The screen
Yes,
is visible. You can start.
Go ahead.
Okay.
Go ahead, please.
Okay. Good afternoon, everyone. Myself, Hemang Upadhyay. I'm working as a senior product manager at LG Electronics. I'm joining from New Jersey. Um, it is really great to see everybody in the same room. Let me start with something we have all experienced. You open up a website and try to book a flight or order something online, and you check the price, right? You get distracted within 5 minutes, and you come back and you see the price actually changed on the website. So we all actually think about what kind of magic is this going on in the back end. Well, today we are going to talk about exactly the same, not just one algorithm, but what happens when many smart algorithms start interacting with each other in the market. So my topic today is about multi-agent reinforcement learning in ecosystem of dynamic pricing. In simple words, if I can explain, this research looks at how AI system learn to set prices when they are competing, reacting, and learning together, and why stability and governance really matters. So, if you look at this slide, you can see how price decisions are influenced by many inputs: inventory, competitor pricing, time of the day, demand signals, and so on. In the old days, companies and rule-based systems, if demand goes up, then you actually increase the price. If inventory is so high, then business tend to reduce the price. Those are the simple rules. But today, the market moves very fast. Data changes every second. New competitor appears. Customer behavior changes constantly. So instead of fixing rules, we use reinforcement learning. The system learns from experience and keeps improving its decision automatically. The challenge is that this environment is highly uncertain and constantly changing. In short, the market does not stand still while the algorithm is trying to learn it. It keeps moving. So let's look at the single agent fallacy that assumes the market stands still while we decide. In this in this area, most traditional AI models assume there is only one decision maker learning in a stable environment. That is what we call like a single agent assumption. But real market do not work like that, right? When one company changes price, competitor reacts. When competitor reacts, then the demand changes again. Everything keeps shifting. So the environment becomes what we call non-stationary, meaning it never stays the same for a long time. Single agent models struggle here because they cannot predict or adapt well to intelligent competitors. It is bit like learning to drive on an empty road and then suddenly like driving on the downtown with the heavy traffic, right? That's like completely a very different experience. So that's exactly how this model works. Let's look at like a multi-agent reinforcement learning explicit model, how we can approach that. So this is where this model comes in. Instead of modeling one single intelligent system, we model many agents which learn together in the same environment, and each agent represent a seller or a platform. When one agent changes the price, the other agent observes it and respond it well. So this creates a feedback loop, right? As you can see in the figure here. Over the time, the agents learn not just how customer behaves, but also how competitors behave. The goal here is no longer like short-term profit only, but learning stable long-term strategies. This makes the model much closer to real-world digital marketplaces. So let's look at the architecture behind it. This, which is called like CTDE, bridges the gap between the theoretical stability and the practical autonomy. CTDE meanings like centralized training and decentralized execution. Now, when many agents learn at the same time, things can become unstable. To solve this, we use something called centralized training, as you can see in the diagram, with this decentralized execution. During this training, the agents share information so the system can understand the full market behavior and learn in a stable way. Once once deployed, each agent operates independently using only its own local data, right? Think of it like a team practice. Everyone trains together, learns their own game plan, but when the match starts, each player plays their own positions. That's exactly how agent works in this environment as well. This approach gives us the stability, privacy, and scalability at the same time. Now let's look at algorithmic pricing, how it improves efficiency but introduces the systematic risk. So AI-based pricing brings many benefits, right? It reacts faster than humans, it manages the inventory better, It responds quickly to demand changes, but it also creates a new risk altogether. Sometimes algorithms start reacting too aggressively to each other. Prices can swing up and down rapidly. In some cases, algorithms can even learn to behave like they are coordinating without any human telling them to do what to do. So while AI optimize efficiency, it can also create instability if we are not doing it carefully. Smart systems still need rules, just like smart drivers still need, traffic lights to manage. So here is a proposed framework for dynamic pricing ecosystem that this research is based on, right? So in this slide, what this framework propose is each seller is modeled as an intelligent agent trying to maximize the profitability under inventory limits. Agents can clearly see their own sales data, but they only get partial or noisy information about competitors, which reflects reality. The market environment capture how like one seller price impacts another seller's demand. This setup allow us to simulate real competitive behavior more realistically. Now, to make this scalable, we use deep learning based MARL algorithm like MADDPG and MAPPO, as you can see. These algorithms help stabilize learning even when many agents are interacting. Parameter sharing allows similar agents to learn efficiently without duplicating the efforts. And this makes the whole system practical for large marketplaces. Let's understand this with the reward design. There is a reward design is a primary governance tool for market behavior. The way we design rewards controls how the AI behaves. If we only reward the profit, then the AI may become aggressive or unstable. So the reward function also includes penalties for instability and optional fairness measures. This encourages the AI to behave in a more balanced and responsible way. In simple terms, we are teaching the AI not just to make money, but to behave well while doing it their own task. What you see here is a regulatory aware architecture. Even with good reward design, we still need safeguards, right? So AI system must be transparent, explainable, and supervised by the human. We also need hard limits such as price caps and monitor mechanism to ensure compliance with regulation. AI should support human decision making, not just replace the responsibility behind it. Now let's look at the methodology that we have followed. This research is completely based on the qualitative analysis of existing academic and industry studies. Instead of running simulations, the goal was to synthesize knowledge, identify the pattern, and build a conceptual framework. Themes like stability, interdependence, governance, and ethics guided the model design completely. The another important thing factor is like safety, trust, and compliance. So future system must focus strongly on the safety and trust. Offline training reduces the risk, explainable AI improves the transparency, and regulatory testing ensures the compliance issues. So trust does not really happen automatically, it has to be designed very intentionally. So just to summarize, markets are very complex ecosystem. Multiple intelligent agents interact continuously, and MARL helps model this reality. Stability comes from CTDE model that we have seen before, and responsible behavior comes from reward design and governance. And these are the references that we have used in the entire research. So I will leave you all with one simple thought. The future of AI pricing is not just about smart algorithms, it is about building responsible intelligence that benefits the business, customer, and society altogether. Thank you so much, everyone, for your time and attention. My details are here. If you have any questions for this research paper in future, you feel free to contact me, and I
Yeah,
look forward for any other questions that you have.
yeah, Himag. This side, Ramesh, actually, you find out the good problem. First of all, the good presentation. And just I would like to ask, you have implemented only deep learning models, or you have included some reinforcement learning algorithms also?
So this model actually includes the reinforcement pricing models, which
Mm.
multiple agent can work together and
Mm.
learn over the period of time based on how the other competitors are producing or changing their price over the time, and then it acts accordingly, right? So it is like there is agentic AI and there is a multi-stack agent AI. So this particular infrastructure will work with the multi-stack agent, where you can still put some guardrails, and with the confidence that agent can make a decision on itself. But if you want a review process, you can have human in the loop, where these pricings can be managed in a different way. So just to answer your questions, there is some level of reinforcement pricing model included in this research paper, but there is definitely a future work required to establish the compliance and safety rules
Okay.
around it.
Yeah, good. And you have deployed these things?
No, no, this is not deployed, but this is on a prototype level. We have implemented it and taken the feedback from multiple users.
Okay, good, good, good. Go ahead. I think you can proceed for the patent and other things also, IPR related, and go ahead. Thank you.
Got it. Thank you. Thank you so much.
Thank you for your
Yeah.
presentation, sir. Before moving on to the next presenter, I would like to announce that our second session chair, Dr. Ganesh Jadhav, is in the meeting. Sir is assistant professor and Department of Information Technology at Prax Vishwakarma Institute of Technology, Pune, India. I'd like to welcome you, sir. Thank you for your presence. Now, I would like to call upon the next presenter.
Good afternoon, all. Yeah,
Yes, sir. Good afternoon.
yes.
So our next presenter is Harsh Bhimsen Pandey for the paper titled Agromyth, an IoT Edge Cloud and AI-generated precision agriculture platform. Over to you.
Hello everyone.
Yeah, you can start sharing.
Yeah. Is the screen visible?
No, no.
Hello.
Yes, it is visible. You can start. Yeah,
Yeah. Hello everyone. Myself Harsh. I am pursuing my BTech from AKGEC Ghaziabad, Ajay Kumar Garg Engineering College, Ghaziabad, and I am here to present my research paper based on the title Agromitra, which is a platform uh, for an AI, IoT Edge Cloud, and AI integrated precision agriculture platform. So, just a minute. Yeah. Coming towards the motivation and problem context, we are tackling for smallholders constraints in India. Basically, farmers have limited access to soil testing facility, high cost of proprietary sensing platform, lack of agronomic advisory at village level, digital literacy barriers for non-English user, unreliable connectivity and power reliability. So we are coming with the uh, research gaps and problem statement. Research gaps is there is no extensible or third party integration, and the IoT at commercial level cost 40,000 to 1,50,000 per range, and dependent, power hungry, requires constant internet, and English centric and advisory, creates digital divide for rural farmers, lack explainability, and no conversational support for the farmer. So coming towards the need identified, and affordable, explainable, multilingual, and scalable system integrating sensing, inference, and advisory for smallholders, farmers, precision agriculture. So coming towards the project objective, what we object to create is a prototype to develop a low-cost soil sensing unit integrated with NPK, pH, moisture, and environmental sensors. Uh, to have a secure telemetry with a latency less than 450 milliseconds, crop and fertilizer models, explainable AI, multilingual advisory, device benchmarking, and scalability exploration. Coming towards the complete architecture overview, so we have IoT sensing layer, which includes ESP32, ROM, and NPK, pH probe, moisture sensor, and DST22 sensor, coming with the edge processing towards the network layer, and have the cloud backend, ML and explainability, and application layer. So uh, the data telemetry flow from 1 to 6, and advisory flow from 6 to 1. So here's coming towards the hardware. We are using a core processing unit ESP32, and for sensor integration we have analog NPK probe, pH electrode, capacitive moisture, and DST22 environment sensor. So uh, at commercial it is available more than 40K plus, but we are bringing this cost to 5.2K. And coming towards the backend and ML pipeline, so you can see ESP32 contacts with brokers with the ingest, and we have storage at timescale DB, ML engine with the app. So model we have implemented in our project is crop recommendation, which use XGBoost classifier ranking, and top K compatible crops based on soil parameters. So we have input as NPK, pH, and moisture, and the crop recommendation model produces the output as probability. And we have fertilizer regressor, which calculate precise dosage for kilogram per hectare required to bridge nutrition deficiency gaps. Coming towards the application, we have Flutter mobile module for a real-time sensor dashboard, nutrition sufficiency indicator, crop ranking visualization, fertilizer dosage advisory, history and trends viewer, with integrated with a multilingual Gemini chatbot. So you can, based on the result generated, you can ask questions like in any languages. Our app supports 29 languages. So in 29 languages, you can ask any questions to regarding farming to our chatbot. Coming towards the experimental model, for the evaluation setup, we have done the slurry preparation, inserted the NPK sensor, pH rod, and make the concentration profile, and repeated this trials. So coming towards the performance matrix, we have repeatability 5% variance, sensor drift analysis 24 hours, E2E latency with millisecond, and packet loss rate is 1% per loss. What is our goal? Power profile, we use MAH as a metric. OTA reliability, so we can uh, update the firmware on over the air reliability. Coming towards the experimental result, we have seen about 2% variance in pH level, 3.5% in soil moisture, and 3 to 6.5 in NPK level. The latency for delivered benchmarking is 250 to 450 milliseconds, and we have low latency as system characteristics, stable sensing performance, and robust telemetry pipeline broker throughput. Coming towards the limitation and future work, current limitations is we have no certified calibration. With the standard laboratory test, and we have limited field trials and long-term sensor drifts. Don't have long-term data. Yield validation as no empirical data yet on actual crop. And what is our future roadmap is for the field evaluation. We will partnership with the agronomy department for rigorous field testing, remote connectivity, integration of solar, LOR, WAN modules for off-grid farm deployment, weather integration for hyperlocal weather forecast for irrigation scheduling, federation learning with localized model on edge device to preserve data privacy, policy and schemes. We will automate guidance on government subsidies and insurance schemes. Coming towards the conclusion, what is Agromitra? It is end-to-end IoT edge cloud architecture, delivering real-time soil intelligence with AI explainability, and it is giving stable performance is less than 5% variance, and low latency less than 450 milliseconds, low cost access as each node cost only 5,200, which is beneficial for smallholder farmers. The scalable foundation as microservice architecture is ready for deployment for 10,000 nodes across regions. Thank you, everyone.
Yes, okay. Tell me how many number of sensor you have used here to collect the data?
Sir, we are using NPK sensor, pH sensor with a DHT22 sensor. So there are, I think, 4-5 sensor.
Okay, okay. So open your system architecture and show me how the data is flow. And which processor you have used here?
Sir, edge processing we are using ESP32 sensor with. So data flow from IoT sensor layer to edge processing layer towards the network layer with a cloud backend for storage, and ML explainability for XGBoost ranking towards the application layer where farmer can see the data based on the result generated.
Okay. And how many languages your application is supported?
So 29 languages we support India, 29 regional languages.
Okay. So you are use the federated learning technique here, na?
Yes, sir. Basically, we have integrated a chatbot based on Gemini. So what result generated is transcribed through Gemini chatbot.
Okay. So your all data is distributed in physical mode and you use the some sensor to collect that data.
Yeah, we use sensor for a real-time collection of data. With that data, we recommend farmers which crop to grow for better profits, and which how much fertilizer required for better better that soil capability, soil metrics to better the farmers' growth.
Okay, you can leave now.
Thank you for your presentation. Now I'd like to call upon the next presenter.
Shall I leave or be in the?
Yeah.
Yes, you can leave. I'd like to call upon our next presenter, Jerush John Joseph, sir, to present his paper titled AI-Driven Workplace, Linkages to Spirituality and Deviance Behavior Among Bank Employees. Over to you, sir.
Thank you. Hope I'm audible.
Yes, sir, you're audible.
You are audible. Start.
Thank you. Thank you. I
Yes,
hope
it is
the
visible.
presentation is visible. Thank you.
Yes. Start.
Hi all, I am Jerush John Joseph, faculty in Christ University. I'm presenting this paper, this manuscript on AI-driven workplace, linkages to spirituality and deviant behavior amongst bank employees. So in this current world, artificial intelligence had changed the nature of working of all types of industries, and it had made a strategic impact on the banking industry, especially on how it operates and also long-term perspective of how banking transactions work. In India, we have private sector banks and public sector banks, especially private sector banks, which are owned by the private parties, and also there is a presence of the public. And these types of banks, they have been adopters of all the technologies, including AI-driven technologies, and their major focus is to enhance the efficiency of the processes, accuracy, and to give customer a good experience in the transactions. As a result of all this adoption of AI, these banks have added automated credit scoring, fraud detection systems, algorithmic trading, robo advisory, chatbots, employee performance analytics. These are some of the activities which are observed among the banks who had adopted AI into their operations worldwide. Especially these three are majorly used in India: fraud detection, chatbots, and employee performance analytics. By adding all these technologies, it is enabling more of a faster decision making process. It is reducing the cost of operation. By adding analytics, it is reducing and also credit monitoring, it is enhancing risk management as well. By adding all this, it is enabling them to increase their competition and also withstand their competition at a larger scale. The private sector banks, they wanted to increase the efficiency and also maintain profitability. Hence, they adopt all these new tools, especially in artificial intelligence, machine learning, and also robotic process automation at a faster pace. There are two impact of adopting such AI tools on workers, especially who are the major stakeholders of the company. It is increasing the efficiency of the company, the banks at one side, but on the other side, it is creating a major impact on like the workers, especially data-driven evaluation of their work is done and predictive analytics is done, because of which it is intensifying their work pressure and their autonomy. That is, their ability to take decision is being reduced, or that is what they perceive. And it has been said that the AI and other technologies are going to take away their jobs. So that is adding up to this amounted pressure among the employees. Because of all this, there is a increasing resistance to the change of adopting new technologies from the employees. And as a result, they might face techno stress, technology induced stress. Emotionally, they can get exhausted. Value conflicts can be there, especially when there is a high pressure environment and they are having targets, they'll have to meet targets. So, because of this, all these reasons can arise. As a result of all this, they can do deviant behavior. They can go away from what is expected from them morally. And these deviant behaviors are voluntary actions which violate the organizational norms and threaten the well being of the organization, wherein because of the pressure of the work and targets, they can deviate from what is expected from them. And it includes withdrawal, maybe going out from the organization, reduce time of working for the organization, rule bending, data misuse, personal aggression, or even unethical decision making can be there arise as a result of this. There is one solution for this. This is workplace spirituality as a variable. This is a construct which has been studied from 1990s as a construct. Again, workplace spirituality is not based upon religion, but it is having three major sub-construct, that is purpose, meaningful work, and ethical reflection of the employees. So this particular study is adding workplace spirituality as a mediating factor between AI-induced stress and also the work deviant behavior. So this is the review done for the top four banks. So these are the top four banks from India based on the market capitalization.
Hello,
So these,
Joseph. Sorry.
sorry.
Complete each part, huh?
Sure, sure. So these are the banks who are using, these are the top four banks who are having the highest market share in India. And these are the tools to move on quickly. So these are the tools which are being used by the banks. The major functions which are used by these banks is for the customer benefit, for a faster or make customers happy. So that is customer service. The second major area is employee training, HR service or HR training is the second area. The third area is like to reduce the risk by employing AI and ML into threat modeling. So these are the three major areas. So with regard to the study, what was the gap identified? So there are studies which are already there on spirituality, deviant behavior, but it is not done on the Indian context, especially even conceptualization, theoretical framework, and also even empirical studies are not done in the Indian context. So that was the gap. As a result, this study has been initiated to examine the role of individual spirituality and influence on deviant behavior, wherein AI tools are used in the workplace. The objectives to analyze the impact of AI on employee work conditions, investigate the link on AI-driven work and also deviant behavior, evaluate the moderating role of spirituality. So interrelationship between spirituality and deviant behavior. So these are the identified impact: increased cognitive load, wherein workers are expected to interpret the AI tools and also the output which is given using the algorithms. The acceleration effect. So using all these tools, they must improve their performance. Loss of autonomy, they are losing out on the decision-making power to the existing algorithms, reduce ownership of decision-making, and what is fair, what is not fair, it is becoming unclear because of the increased usage of AI shift. So these are the perspectives of employees. And as a result, they are having some of the impact, including technology-induced stress. As a result, they might not upskill themselves, job insecurity, surveillance pressure because of constant evaluation. Uh, Deviance as retaliation. They might retaliate, they might not adapt to this change, they might misuse the system. As a result, they try to come up with any of the gaps which they can identify from the system. And the solution, as per the review, there can be internal control and external control, which should be made by the policymakers or the management of the team, management of the institutions or all these private banks. Spirituality should be there, wherein it is not religious, but meaningful workplace should be created. A sense of belongingness should be created. As a result, they will be sticking on to their workplace. They'll be using this technology and all these tools in the right way, and it is going to reduce the frustration they have. The major problem identified in the review is value misalignment in the modern banks. So the major objective of the bank is to increase efficiency, wherein the human beings are ignored. But as per the study, this value misalignment should be removed, especially from the policy implication part. Major challenges and recommendations. Major challenges I have mentioned a bit. So going to the recommendations. So from the employee perspective, the AI should be used for targeting upskilling of the employees and also providing psychological support. These are some of the solutions which should be given to the employees as stakeholders. From the perspective of managers who are using AI, so there should be AI ethical frameworks which should be there for the leaders and managers. Value-based leadership practices should be followed in the organization. From the organization's perspective, the recommendations are there should be transparent AI system wherein they are having a clarity, employees are having a clarity on what to do and what not to do. There should not be any difficult metrics. The metrics or the calculations or frameworks should be simple and it should be made available for everyone. And stability in monitoring each and every process which are present in the organization. For the policymakers, they should be having a regulatory safeguard wherein all the stakeholders, including the employees, are protected. There should be accountability from the organization's part, and the data which is collected by the organization should be safeguarded as per the new regulations. So the conclusion of the study, it examined the interrelation between AI-driven work environment, spirituality as a construct, and also deviant work behavior. It is going to become more complex in the upcoming for the upcoming generations, especially for a private sector bank. In that perspective, they should enable AI systems and also they should focus on the stakeholders rather than more focusing on their customers. So that is it from my end for the presentation. Thank you. I'm open for questions.
Thank you for your presentation, sir. Ganesh sir, do you have any questions?
Yes. Show me your system architecture.
Sorry.
Yes.
Hello, sir. Hello, sir. I was not able to hear the question. Hello, sir. Could you repeat the question?
Hello, am I audible now?
Yes, sir. You are audible now.
Yeah. So show me
Yes, sir.
your
Could you
data
repeat the
flow
question,
and
please?
system architecture.
So this was a review paper. It was a theoretical paper wherein the diagrams are not there. So it was a review paper.
Okay. So what is
Okay.
the gap analysis?
The gap analysis, it was based on the literature review. There were no studies conducted in the area, the combined area of artificial intelligence workplaces and also work spirituality. And also there was one more construct that was work deviant behavior, which is negative behavior, which is happening in an environment because of the or AI or any of the technology which has been adopted in the workplaces.
Okay. And show me also your
Mhm.
literature summary.
Literature summary. Just give me a
Ah,
second, sir. I am just opening the paper. I hope the screen is visible.
no.
No, just a
Yes,
sec.
yes.
I hope the screen is visible, sir.
Yeah.
Yeah. So this was a theoretical background based on the literature. The gaps were identified, and workplace settings and spirituality as a construct, and the interrelationships were identified. It was a pure review of the literature using which the gaps were identified and recommendations were made. So I'm just showing you the recommendations also. These were the recommendations at 4 level which was made.
Okay. You can leave now. Ma'am, next.
Thank you.
Thank you for presenting, sir. Now I'd like to call our next presenter, Dimple Kashyap ma'am, to present her paper titled An Intelligent System for PCOS Prediction Using Machine Learning Techniques. Over to you, ma'am.
Good afternoon, everyone. Is my screen visible?
Yes, ma'am, the screen is visible. You may start presenting.
Okay. Good afternoon, everyone. My name is Dimple Kashyap and I'm from Pune University. And today I'm pleased to present our research topic titled An Intelligent System for PCOS Prediction Using Machine Learning Technique. First, we will start with what is PCOS. PCOS is a polycystic ovary syndrome, which is a prevalent endocrine disorder that impacts majority of women in their reproductive age. It causes hormonal imbalance, infertility, metabolic issues, psychological stress, and in rare cases, gynecological cancers. It affects about 4 to 20% of women worldwide, but in India, its impact is around 4 to 23%, which depend on citizens and other demographic aspects. But yet, 70% of females remain undiagnosed, for which early prediction is important so we can prevent long term complications. And for this, machine learning can enhance early and accurate PCOS prediction. There are some research gaps in current PCOS research, that is, limited use of statistical features. Second, the absence of cross validation. And third, critical need for interpretability. So, our objective for this research is as follows. First, to identify the key features by using chi-square test. We identified top 10 features with the help of chi-square test. Second, to develop a machine learning model for easy and accurate PCOS prediction. Third, to enhance reliability by using five-fold cross-validation. And fourth, to compare different models and to find the one best suited model for prediction of PCOS. Here's a description of our methodology. First, the dataset consists 541 samples with minimum number with 43 features. For data pre-processing, there is thorough cleaning and imputation of missing value that is done by using medium of particular of that particular column or that particular attribute. For feature selection, chi-square test is used and the top 10 features were selected. We had used 80-20 train test split and it is coupled with five-fold cross validations. The algorithm that are used in our model are random forest, SVM, decision tree, logistic regression, and KNN. This is the pipeline of our research. First, we acquire data. Then for data pre-processing, we go through data cleaning and data encoding. In data cleaning, we remove unwanted attributes, and for missing value, we use we imputed median of that particular attribute. For feature selection, we used chi-square test and we selected top 10 most effective features for PCOS prediction. For model selection, we have used 5 algorithms. The data is split into train and test with 80-20 ratio. Model is trained and tested on basis of 2 categories, cross-validation and without cross-validation. These are the parameters that are used in our model. For random forest and decision tree, we had used entropy to measure the quality. For SVM, the kernel is linear. For KNN, we had used metric that is MNOX. Here are the results for random forest. Our model had achieved 92% accuracy, which is the best accuracy out of all the models. And it is consistent for accuracy, precision, recall, and F1 score. It is 92%. And with regard for cross-validation, the accuracy reaches to 86%. Next comes support vector machine. We had used a linear model that is used to find the best fitted line to divide the data points. Our model show 87% accuracy, and for the cross-validation, the accuracy reaches to 86%. Third is decision tree. Our decision tree show a consistent result of 86% for all the parameters, and for cross-validation, the result reaches to 82%. Next is the logistic regression. Our model show a consistent result for all the parameter of it for 85%, making algorithm dependable on linear relationship. When cross-validation is enforced, the accuracy reaches to 78%. And last algorithm that we had used is KNN. So KNN showed the least accuracy and it performed relatively compared to the other model. It performed poor as compared to other models, and it acquired an accuracy of 72% with a poor F1 score of 68%. That means it is sensitive to noise. And when we applied cross-validation on KNN model, the accuracy remains same, that is 72%. This is the confusion matrix of random forest on the tested data. It provides a detailed breakdown of our random forest. It's showcasing its strong ability for classifying PCOS and non-PCOS cases correctly. Our data set for test in our model, with the test data set of 109 samples, our model show effectively identify the majority of true positive cases that are not PCOS cases, that is 30, and true negative cases that are non-PCOS cases, that are 70, which demonstrate only a minimum misclarification, that are false positive and false negative, that are 2 and 7 respectively. Our research demonstrates a significant potential of machine learning and diagnosing PCOS. Random forest provide the best and robust model for among all the tested models. Chi-square test is used for feature selection to enhance the model's interpretability. Our model support early diagnosis, providing a timely treatment and improved patient outcome. Yet, while our study yields promising results, but yet there are some limitations in our study. First, the data set is relatively small. Secondly, the data set is from a single source, so it can introduce biasness and reduce generalizability across different populations. Third, although we had used cross-validation, but there is absence of real-time deployment, so which indicate the need for further validation in live clinical settings. Fourth, the limited demographic diversity is within the data set, which underscored the importance of inclusive data collection in future studies. Here are the future works. Our research based on our research, these are the future work that we can work on. Firstly, we can integrate imaging data. We can integrate clinical and biochemical data with ultrasound image. Secondly, we can deploy a user-friendly web-based clinical decision support system for early access. Third, we can test our model on diverse population. Fourth, we can implement explainable AI to enhance transparency in diagnosing of PCOS. To conclude, our model provide a method for enhancing early prediction of PCOS using machine learning that aims at creation of clinically interpretable and relevant characteristics. We had implemented chi-square test to identify top features, which enhances the method. Cross-validation is also implied, which reduce overfitting and make the model suitable for deployment in practical world. So we can, so medical staff can use it in early detection and treatment can be started promptly. Our research demonstrates the significant potential of machine learning in revolutionizing the diagnosis of PCOS. These are some references that are used. Thank you, and I'm ready for your questions.
Thank you, ma'am, for your presentation. Ganesh sir, do you have any questions?
Yes. Am I audible now?
Yes, sir, you are audible.
Yes, sir, you're audible.
Yeah. Open your motivation slide if you have added in presentation or not.
Sir, can you repeat?
Motivation.
I don't have any motivation slide in it, but I have some end caps which motivated me to do this. And secondly, firstly, I'm also suffering from PCOS. It is one of the major reasons that I had worked on this particular field. And secondly, although it is a very common endocrine disorder, but yet there are many women that remain undiagnosed due to lack of knowledge and other perspective due to lack of healthcare.
ठीक है. Why you are not added the other parameters? You have only add the accuracy in comparison of result. You can add the precision, recall, F1 score.
Okay, sir, it's an important point. I'll remember in for next presentations.
Yeah. You can add that one in
Okay,
comparison also, because you only use the one parameter to compare the all method.
Yes, sir. For presentation, I had used only one parameter, but when I was working on it for the paper and for the publication, I had compared other parameters also, but it's my fault that I had only one parameter in presentation. It's my fault. I'm extremely sorry for it.
ठीक है. Yeah. Ma'am, next one.
Thank you, sir.
Okay, thank you for your presentation. I would like to now call upon our next presenter, Kirti Pradyun sir, to present his paper titled Architectural Analysis and Optimization of C Programs Using Call Graphs. Over to you, sir.
Yeah.
Yes, you can start now. Your presentation is visible now.
Okay, sir. Sir, is the presentation visible properly, sir?
Yes, it's visible.
Okay. Good afternoon, everyone. I am Pradyun. I am from University of Hyderabad, and I am presenting on the topic architecture analysis and optimization of C programs using call graphs. We have used a strategy I have developed, that is the SSCA strategy, to go through this. The main problem that comes to C programs is the deeply layered spaghetti code that is tough to understand and maintain or understand the complexity of each C program separately. We can use certain compiler optimizations like GCC03, which can show what the architecture differences are. But these are black boxes which do not show that complete total total understanding of the C programs. So why current approaches fail? Existing tools fail to bridge this gap. Static extractors give us data but lack architecture interpretation. On the other hand, traditional network analysis is purely descriptive. It shows us the graph but doesn't tell us how to fix it. There is a major disconnect between the static metrics and the dynamic profiling. So we can't optimize it with the given data. Like if we go through a larger data set in a C program, we don't know whether it will go through or not. And our methodology is a way to solve this problem. We propose the static structural call graph analysis, SSCA strategy. This is a white box methodology designed to turn raw data into actionable insights. Our three key stages are extraction, metric computation, and filtering. Extraction is where we use standard tools like Doxygen and Graphis to pull out the call graph from the C programs. Metric computation, we use advanced metrics like bitwitness centrality, the cycle disk, and the PageRank system to quantify the influence of each function in the C program. And we separate the signal from the noise to find the hotspot that is the main part of the program and filter it to optimize the main program. The main core metrics we have used is a structural centrality score, SCS. This is a composite score that tells us how important a function is to the architecture. It combines metrics betweenness and page rank. Betweenness centrality identifies the bridge functions, and page rank identifies high utility functions. So a combination of both of this is the structural centrality score that we have used in order to run SSCA. And we also use out degree, that are the number of functions that a function calls in order to run, and that is the out degree of each function. And how do we differentiate between signal and the case study setup? To validate this, we conducted an empirical study on a C program structured with 13 functions representing various patterns like dispatchers, recursive cycles. We used Oxygen for extraction and GNU profiler, that is gprof, to measure runtime performance. We also ran this on a larger C program base, that is Redis files and SQLite files. We have also extracted through Doxygen and ran gprof on it. We have used NetworkX to metric compute each of the programs, and this proved to be efficient in order to understand and optimize it to reduce the bottlenecks and make it faster. How do we differentiate between signal versus noise? The results were revealing. Structural signal and runtime noise. A function named process acted as a central dispatcher. It had a very high structural score, that is 0.69. This confirmed it has architectural importance. In contrast, leaf functions, that are the end functions like multiply, add, consumed 99% of the runtime, but had almost zero structural importance. Using SSA, we filtered out 30% of the graph as noise, allowing us to see the actual code of the system. And diagnostic rules. Based on these findings, we established 4 diagnostic rules for optimization that are: high centrality score and high runtime are priority bottlenecks. Refactoring here improves both architecture and speed. Low centrality score and high runtime are pure optimization targets. Focus on the algorithm, not the structure. And high centrality score and low runtime are the structural backbone. These are critical for coordination and must be handled with care. Low structurality core and low runtime have minor impact and can be ignored. So the robustness and scalability of the program. We tested the robustness of our score. A sensitive analysis showed that even if we vary the metric weights by 15%, the top critical functions remain the same. We also successfully detected modular structures within the code. We have already scaled it to a larger C system, multiple C program file system to optimize them too, and it worked perfectly. The conclusion, in conclusion, SSCA shifts the paradigm from simple visualization to optimization. It helps developers focus on what actually matters architecturally. Looking ahead, we aim to integrate SSCA with CI and CD pipelines to detect architectural drift automatically. We are also exploring in using LLVM models for higher precision in extraction. Thank you for your time. These are the references we have used. Any questions, sir?
Yes. Okay, show me your feature scope.
Sir?
Feature scope.
Can I
Explain
share
your feature
the
scope.
can I share the paper,
Yeah.
sir? It has the algorithm we have used and also the cycle graphs.
You have
This is
used the different case studies, na?
yes, sir. This is the algorithm we have used, the basic general
Uh,
algorithm, and we have used it
uh,
on a function, on different functions, that is 13 functions. And this is the call graph of the case study program.
hmm.
And after we have reduced the call graph by giving us a certain percentage of amount, that is SES score, to see it as an important function, and this is the reduced. We can change this centrality score in order to get into more functions or see the actual score. But these 3 functions are the main called functions in the 13 function program, sir.
Okay. And what is the motivation part?
Motivation, like when I have started learning C programming, it was tough for me to understand a large subset of programs. So in order for others to understand it perfectly and know which function goes to which function, by simply seeing the graphs, I have come to this conclusion. And after going through the call graphs, I have also come into the thought that I can optimize it to the call graphs. So this is how I have done it, sir.
Okay, you can leave me.
Okay,
Ma'am,
sir.
next one.
Thank you for your presentation. Now I'd like to call upon the next presenter, Shrikant Malviya, to present his paper titled Cloud Narrative Architectures for Regulated Financial Platforms. Over to you, sir.
Hi, can you see my screen?
Yes, sir, the
Yes,
screen is
you can
visible.
start now.
Yeah, hi. Good afternoon, everyone. My name is Shrikant Malviya, and I will be presenting the paper titled Cloud Native Architectures for Regulated Financial Platform. This is a work that has been co-authored by Parth Joshi, Harsh Pandekar, and Abhishek Dikshit. It focuses on how modern cloud native architectures can be systematically designed to meet the strict regulatory requirements of financial institution. Uh, Here's the agenda for today's talk. I'll begin with problem motivation, followed by brief literature and regulatory context. Then I'll explain the research approach, summarize the key findings, and walk through the proposed reference architecture. I'll conclude with a decision of benefits and challenges, and finally, a conclusion and future research directions. Regulated financial institutions such as banks, payment processors, and trading platforms face a dual mandate. On one hand, the must modernize aggressively to support real-time analytics, digital channels, faster product delivery. On the other hand, they must remain demonstrably compliant with the strict regulations governing data protection, operational resilience, and the risk management. Cloud native architectures based on microservices, containers, Kubernetes, and CI/CD have emerged as a powerful paradigm to support scalability and agility. However, these architectures also introduce new risks, includes third-party cloud dependence, operational resilience challenges, and multi-jurisdictional data residency constraints. This leads to central research question of our paper, which is how can cloud native architectures be designed systematically to address the true requirements of regulated financial platforms. We begin by grounding our work in establishing established cloud native principles. Cloud native systems are composed of small, loosely coupled microservices, typically deployed in container and orchestrated using platform like Kubernetes. They rely on declarative infrastructure as code and automated CI/CD pipelines. For financial platforms, these principles enable frequent deployments, lower mean time to recovery, and tighter alignment between business capabilities such as payment to or KYC and technical services. However, these benefits must be evaluated in parallel with regulatory obligations, not independently of them. Regulated financial platform operate under multiple overlappings regulatory frameworks. In the European Union, the Digital Operational Resilience Act or DORA establishes binding ICT risk management requirements and introduce direct oversight of critical third-party cloud providers. BCBS 239 mandates accurate, complete, and time risk data aggregation across complex IT landscapes. GDPR imposes strict requirements on lawful data processing, minimization, and data subject rights, even in hybrid cloud environment. Sector specific standards such as PCI DSS, AML, and KYC further require encryption, logging, segregation of duties, and incident reporting. In addition, regulators have raised concerns about cloud concentration risk, emphasizing diversification and governance of cloud service providers. Moving on, the literature shows a clear transition from monolithic core banking systems to microservice based architectures. Microservices enable modularity, high availability, and faster release cycles, but they also increase complexity in areas such as distributed transaction, security, and observability. Advanced patterns such as service meshes, event driven architectures, and zero trust networking have emerged to manage this complexity while supporting regulatory requirements. Importantly, governance research highlights that European Union cloud regulation is shifting from traditional operational risk rules towards the high level regulation and direct supervision, particularly under DORA. This reinforces the need for architecture that are not just cloud native, but regulation native. Our methodology, we adopted a conceptual synthesis approach rather than an empirical case study. The research proceeds in three stages. First, we conducted a document analysis of peer-reviewed and pre-printed literature on cloud-native architecture in financial services, focusing on work published between 2019 to 2025. Secondly, we reviewed regulatory text and supervisory guidance including BCBS 239 and DORA. Finally, we applied design science synthesis to integrate cloud native patterns with regulatory and governance requirements. The result is normative reference architecture representing a target state that can adapt across jurisdiction and business models. Our key findings show that architectural objective for regulated financial platforms go beyond and non-functional requirements. Key objective includes regulatory compliance by design with built-in controls of auditability and reporting, operational resilience, including a fault tolerance and disaster recovery patterns, risk data aggregation and transparency are required to meet BCBS 239 obligations. Finally, vendor and concentration risk mitigation requires support for hybrid and multi-cloud deployments. These objectives form the foundation of proposed architecture. And this is our proposed architecture. Based on these findings, a layered reference architecture for regulated financial platforms. At the top is the channel layer, including mobile apps, web clients, partner APIs, and so on and so forth. Below, this is the API edge layer consisting of API gateways. Then we have business service layer contains domain aligned microservices such as payment, account, KYCs, risk reporting running on Kubernetes cluster. Then we have a data and analytics layer support polyglot resistance and streaming platforms, strong encryption, lineage tracking. Then here comes the security compliance layer into centralized IAM, secret and key management, tokenization, fraud detection services, and policy as code engines. And finally, platform and infrastructure layers support multi-region and hybrid clusters, cloud deployments, and service meshes, observability, and CI/CD tooling. Moving on, the architecture embeds security and compliance mechanism directly into platform. Zero trust ensures Zero trust networking ensures that every service to service call is authenticated and authorized. Service meshes provide mutual TLS traffic control and detailed audit logs. Cluster and namespace isolation helps segregate regulated workloads. Cloud native IAM supports strong customer authentication, policy based access control, and identity lifecycle management. Data protection is enforced through encryption at rest and in transit jurisdiction, specific key management, and residency aware routing. Finally, policy as a code and CI/CD automation enables continuous compliance and checks automative evidence generation of audits. Our analysis indicates that cloud native architectures can significantly increase deployment frequency, improve elastic scalability, enhance operation resilience. This benefit aligns closely with regulatory expectations and continuity of critical functions, risk management, consumer protection. However, the challenge remains distributed system, increased complexity, and observability challenges. Cloud concentration risk introduce systematic concerns. Multi-jurisdiction regulations may impose conflicting requirements, and there is also a notable skill gap in cloud native security and governance. Hybrid and multi-cloud approaches can be mitigated, and some risk can be mitigated, but introduce additional operational complexity has to be done. In conclusion, cloud native architectures are becoming foundational for modern financial platforms. However, for regulated environments, cloud adoption must be treated as regulation driven architectural transformation, not merely a technical one. By embedding compliance, security, governance into our architecture itself, financial institution can build a platform that are not only cloud native but truly regulation native. Future research directions include verifiable compliance and mechanism, cross-border regulatory harmonization, and energy-efficient microservices. Thank you so much. This is all from my side, and here are the list of references that we have used during our presentations. Please feel free to reach out to me for any questions, and Dr. Ganesh, if you have any questions, please let me know.
Yes, this is your literature review paper.
Yes.
Okay, show me your gap analysis.
Okay. So this is gap analysis. Cloud native benefit
Okay,
discuss elasticity, faster releases, no integrated architectural view that systematically aligns native platform with regulatory obligations.
ठीक है. Show me your literature survey analysis. Literature
Yeah,
survey summary.
yeah. So you want me to open the paper, or I could just show on the
Yes, just
presentation?
show on the PPT, or you can be open the
Yeah.
paper also.
Yeah, so this is my literature review, which includes cloud native principles, then how regulatory landscapes and requirements look alike, and then what type of microservices and governance are needed for cloud native architecture in terms of regulations and international laws. And these are my research approach.
ठीक है. And what is the security part is important in your system? How you use the
Can
security part?
can you repeat the question, Dr. Ganesh?
How you use the security part in your system?
Okay. So, security in our system is not treated as separated, but is embedded across the architecture layer itself. First, we make sure the network and communication, we use zero trust security model, and it is embedded within the service itself. Along with that, we have identity and access management layer, which ensures a cloud native security. Another is customer authentication and identity lifecycle management. Third is we wanted our cloud native architecture to be compliant with international laws and regulations in terms of data protection, and that should be applied through encryption at rest and in transit data, and key jurisdiction specific and location specific data residency requirements such as GDPR, European Union, and DORA. And yeah, we also have policy as a code itself embedded as a security pipeline, and we use DevSec operations practices and best compliance and regulatory practices. Any further questions? Am I audible? Hey, Dr. Ganesh, your voice is breaking. You're not audible. Can you hear me? If Gayatri and anybody could respond, because
Hello,
hey, can you hear me?
sir. Yes, sir, you're audible now.
Uh, like,
Hello, Ganesh
do
sir.
Dr. Ganesh have further questions, or I can just stop sharing?
I think you can stop sharing. Ganesh sir, your voice isn't audible. I would now like to call upon the next presenter. Thank you for presenting, Shrikant sir.
Okay.
Now, I'd like to call upon our next presenter, Prashant Kamal sir, to present his paper titled Comparative Analysis of Log versus Reg 709 Color Profiles in Indian Film Production. Over to you, sir.
Okay, okay. Yeah, it's visible. You can start direct your presentation. Yeah.
Am I audible?
Yes, sir, the screen is visible. You may start.
Ready. Just a second, ma'am. Just a minute. So, my topic is a comparative analysis of log versus Rec 709 color profiles in Indian film production. In this paper, we have two co-authors, Dr. Sabnam Patnaik and Mr. Jain Prabhakar Rani. How to change this slide? In digital cinematography, choosing between log and Rec 709 color profile shapes creative intent, workflow, and final output. With the widespread adoption of digital cinema camera, this study systematically compare both profile within Indian cinematographic context, offering industry-informed guidance for cinematographers and post-production professional, balancing creative, technical, and financial properties. In methodology, this study employs an experimental qualitative analytic methodology to compare the technical and workflow characteristics of log and Rec 709 color profiles in Indian film in production. The approach is adopted from professional DI studio practices and follows the experimental framework to the references let's studies. Let's means it's a part of plugins. Now you can see this table. This slides highlight the limitation of Rec 709 in Indian film production. While it offer contrast-rich, ready-to-view footage and faster workflow in struggles with high intensity daylight, mixed lighting sources, vibrant colors, diverse skin tone, and limited flexibility for advanced cinematic grading and dynamic range requirements. We did trial run. During this trial run on the chroma set, we can understand in easy words like blue screen. You have seen blue screen or green screen. Several technical issues were identified during live capture. Lighting errors were most frequent, causing uneven illuminations and shadows. Additional problems included color spills from the background and camera-related issues such as focus, exposure, inconsistency, affecting overall images quality. In trial run issues, we have got some impact and resolutions. This summarized keys issued identified during trial run, including exposure, consistency, highlight clipping, saturate, biased, workflow latency, and multi-camera mismatch. It outlines their impact on image quality and grading efficiency, along the practical resolution such as calibrates, LUTs, exposures, adjustments, chart-based correction, GPU optimized workflow, and standardized color pipeline. We have done experimental and got some analysis. This experiment employed the Blackmagic Pocket 6 Pro for streamlined Da Vinci Resolve workflow. Typical Indian cinematography scenarios were captured in both log and Rec 709, including daylight exterior, evening markets, studio interviews, and low lights interior. The analysis focus on dynamic range color accuracy grading flexibility, and workflow efficiency. In this slide, compares video formats based on the file size and metadata depth ranging from Rec 709 to raw formats such as Aries RAW and BRAW. It illustrates the how higher ends format and increased data richness, wide dynamic range, and greater grading flexibility, while compressed format enable smaller files and faster workflow. The color pipeline workflow compared log and 709 profile raw and log workflow preserve higher dynamic range, metadata, and grading flexibility, but the required large file size and post processing. Rec 709 using compressed capture offer a direct monitoring, minimal grading, smaller files, and faster SDR ready delivery for standard viewing. And this in this table compare bit depth of data rates across format, emphasizing two traits of between file size and post-production flexibility. Raw and pro resolution 4444 support maximum dynamic range for the cinema and VFX pro resolution 422 high quality suits. Professional broadcast, while the Rec 709 enable efficiency deliver for social media and live television. In challenges and limitations, log footage appeared flat compared to Rec 709, making exposure judgment difficult for less experienced operators despite using monitors LUTs. I have also discussed about LUTs. LUTs means it's a part of plugins. Differences in color pipeline infrastructure cause low workflow and to be effect mainly in the high-end production, limiting constant evaluation in smaller setups. Control test conditions failed to represent the fast-paced dynamic lighting environment typically for Indian cinema. And also log profile provide wider dynamic range, smoother highlights, and superior grading flexibility, making them ideal for cinematic, VFX heavy, and SDR OTT. SDR means high dynamic range. It's a type of image, high quality image. OTT content, Rec 709 suit broadcast, and low budget production. Due to its speed and simplicity, Indian cinematographer must choose profile based on narrative needs, resources, and involving SDR and global streaming standards. Thank you, sir. Any question?
Yes, explain your workflow.
Workflow. I've recorded some short videos. Then I have edited in DaVinci Resolve professional softwares. DaVinci Resolve also some uses plugins, LUTs to find out the final result to what we have recorded before, and after that what we have got.
Okay. Have you used any data set? Or
Sorry?
it is your data set? It is predefined data set, or you generate the data set for that one?
I have generated all the data.
Okay. And which algorithm you have used to convert the actual image to the high resolution image?
Yeah, it's a. I have worked. I have used two software, the Vinci Resolve and two plugins. Two plugins means two techniques, plugins and LUTs.
Okay. And what is the difference between them?
Sorry, what's the difference between
These two techniques.
before and after this slides in this slide?
Yeah.
Actually, before this first image is shows that before the record when I recorded this that time this result was got. After that, when I added some effects and LUTs, then I can increase the quality of the image and enhance the quality of colors. And after that, we have got final result.
ठीक है. And what is your features? Feature scope तो नहीं होगा ना शायद. There is no any specials.
No, sir.
ठीक है. Yeah.
Okay.
Yeah, you can leave now.
Okay, thank you, sir. Thank you, sir.
Thank you,
Yeah.
sir, for your presentation. Now I'd like to call upon the next presenter. Shobit Singh to present his paper titled Enhancing FIR Drafting via Graph, RAG, and LCR Net, a hybrid framework for legal aspect extraction in the Indian justice system. Over to you, sir.
Yes,
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 ma'am.
yes. Start.
Let me share my screen.
Yes, sir.
Is it visible?
Yes, sir, the screen is visible. You may start
Yes, yes.
your presentation.
Yes, start.
Okay. Good morning, everyone. I am here to present my paper, Enhancing FIR Drafting by Graph, RAG, and LCR Net. This is a hybrid framework designed especially for the Indian justice system to solve the official problem of legal aspect extraction. This work was conducted at the Department of Information Technology at Ajay Kumar Gar, Ghaziabad. So let me go through the introduction and motivation of this paper. Let me start by highlighting the scale of this issue. The Indian judicial system is overwhelmed with a backlog of over 4.4 crores cases pending as of 2024. A significant root cause of this delay is the poor quality of first information report filed at the initial stage. What is the gap? I identified that the frontline police officer often lack formal education. This problem is currently aggregated by the historical legal transition from the Indian Penal Code to the new Bharatiya Nyaya Sanhita (BNS), which were formed in 2023. Our objective to develop a LIA, legal intelligence application, an AI system that assists officers by analyzing crime narratives and recommending the correct BNS sections with legal explanation. So what is our problem statement that we are solving? The shift from IPS to BNS, the Bharatiya Nyaya Sanhita, has restructured offense definitions. Officers must only unlearn decades of precedents. For example, theft was section 378 in IPC, but is section 303 in BNS. Manual mapping is error prone. That means the manual mapping of the case is very error inefficient. What is the risk in this AI? The normal legal, just like the Chat GPT, Gemini, they are the very prone to hallucination. They often predict and depict the false narratives. They often recreate their imaginations and drop their output. In a legal context, citing a fake section is catastrophic. It can lead to very serious legal, the consequences. Let me move on to the literature survey and the research gap of our paper. Rule-based system. Early models like Taxman, it is a very old model that was developed, used deductive logic, but failed as scalable because they could not handle complex, unstructured narratives that the modern legal laws are coming with. That's why we identified that the legal but model that was previously used, we also trained this model in our college using very high-end computers, and we also tested the efficiency and all. While the legal but understand legal language well, it lacks contextual knowledge. The real the core of the law, what is happening at the police station, it didn't know that. That's why we identified and work on it. The hallucination that we just mentioned, it's I'm giving there is example of that, that the existing RAG model struggle to distinguish between the semantically similar but legally distinct crime, such as theft, section 378 IPC versus extortion section 388 383 IPC. That are very common but slightly distinguishable. Also, there is lack of concept that standard LLMs that ChatGPT do not enforce legal hierarchy. They didn't know what are the hierarchy of the cases, what should be a conspiracy charge without a main offense, leading to a logical error. Also, let's move on to proposed methodology. Just like the input narrative, that we can insert both English and Hindi text in the LLM, and it will generate the output. So what is the it is an advanced version of more LLM, LCR net, which is mainly built for this legal and official laws that are coming up nowadays. Our approach is the neuro symbolic architecture. Mainly neuro symbolic is the related to very humankind, what a officer do, what a police officer do in a police station. It's mostly same at like that. First, the LCR net parses the narrative to separate the intent mens re from the act accessory. These are the technical terms that are uh, given to these acts. Second, a legal language graph NOE4J validates this prediction against the actual BNS hierarchy. That means our LCR net justifies and reads the hierarchy of the laws that are mentioned in the Indian Penal Code and BNS, and then it gives the real judgment of what is happening. This ensured that the AI cannot recommend a punishment without a valid offense. That means AI cannot pass a judgment without justifying the hierarchy, justifying the cases, justifying the proofs, and everything that it is given to that. So let's me move on to the result and discussion part. This is an screenshot of our Excel table that we just created by comparing the other models and the LIA that we are proposing. And we have seen that there is an improvement of several percentages of against the other models. As you can see there, we have also compared the macro, micro and macro scores of the other models also. This is the we also observed that there is an overall 94.1% legal consistency compared to just 78.2% of the previous models, which is very popular legal. But what this means is the high consistency score proves that the system respects legal logic. Example, ensuring mutually exclusive charges like murder and suicide are not predicted together. Let's move on to the case study of the yes. This is the case study that our system gave the answer. Just like there is a scenario: two men on a bike snatch the chain from a victim, causing her to fail and suffer injury. So what the standard LLM like ChatGPT will give prediction IPC 379 theft. It would only judge it by the theft, that the bike snatcher snatch the chain and gone away. But what the modern LI system that we are proposing will give the answer, that the theft plus criminal force as snatching. It correctly invokes subscription because it detected the injury, that the victim also suffered from injury, applying the stricter new law. But as we are comparing with ChatGPT, it only gave that there is a snatching possibility. So it only give the IPC 379 Act. So what is the conclusion, that we have achieved 94.1 efficiency, and we have tested it from a very big data set from Kaggle. It has a data set of Supreme Court from 1974 to 2024. We have also the links of the data set, and we have download it physically on our computer, in our college computer, because our normal computers can't handle it. It is almost about 57 or 84 PDFs about data. What are our
Yeah.
future scope and
Okay. So just show your comparison result and justify it.
I can open my research paper. We have also
Yeah.
included this table in my research paper.
Because here you use only the two parameters, F1 score, F1 and accuracy. So you can be use the multiple parameters also.
Yes, we have also used multiple parameters, but sorry for me, didn't make the table and depict it in the PPT. We will try our best to depict the real cut, because it is our college computers, and so due to some misunderstandings or something from my team members, we are not able to generate the table of the other parameters.
Yeah, so show your paper. Okay, result section.
Okay. Yeah, this is the table that I am saying.
Here is also be the only two parameters.
Yes, we will
Okay, you can
also do.
add the multiple parameters to compare
Yes, yes,
the.
yes.
System.
We will
Okay,
try to do.
What is the motivational part to select that one?
This project, it's
Yeah,
an personal experience. When we go to the police station and all, they didn't know the laws and everything, the police officer. That's why the idea came, that why not the police officer get this type of LLMs and modern computers, that they can enter details and get the real crux of what happening in the Indian penal code, and what is BNS. Even a police officer didn't know what is a BNS, that the sections are different. That's why this idea came into our mind, and we decided to build a project on it.
Are you define the literature summary in your paper?
Literature summary. Okay, wait, I'm going to the. These we have studied the previous works and all the research papers, and we have extracted the what is have been done till now, what is and we have justified that they are working on a legal BERT model, but it's in an outdated version. That's why we came up with an LCR upgraded version of this model, and we have implemented algorithms. We have also pasted the algorithm and formulas that we use to train the model. If I can just show the algorithm.
And what is the workflow? Show me the workflow, sequential workflow.
Sequential workflow. I have added the algorithm. Wait a minute.
Yeah.
My computer froze.
Good afternoon, sir. I am the second co-author of this. The workflow goes like this. While incrementing our Kaggle dataset, we present a pipeline of process flow. First, we have step one. We have ingested the data, the input layer. The system receives the raw FIR, and we utilize the datasets of crime narratives sourced from Kaggle, which combines description of incidents and mixed languages. Secondly, we have fine-grained aspect evaluation extraction using our LCR net model. What does the LCR net model do? Unlike the standard models that reads the whole text at once, while and breaks down our Kaggle narratives, the LCR net model breaks it into legal ingredients like legal context, center target, act and weapon use, right consequence, and consequences. Secondly, the hybrid retrieval. That's a step three. Out of our process pipeline, the search. The system searches for the correct law for using two simultaneous methods: the vector search and the knowledge graph traversal. That is NIO4J. It moves through a structure of the graph through Bharatiya न्याय Sanstha and finds laws that are logically connected, connecting to theft or any particular crime that has been committed. And the next is step four is the legal validation, the filter, the engine constraint enforcement module. The process before giving an answer, the system cross checks the prediction against the legal knowledge graph. The logic check, it applies rules to prevent hallucinations. For example, if a model predicts a punishment, the graph ensures it is linked to a valid offense definition in the BNS hierarchy, that is Bharati Nya Sanstha hierarchy. If the prediction violates legal logic, it is discarded. And the next process for the process pipeline is the output and explanation. The system outputs the final recommendation BNS section. The value, it does not give a section number, it provides a reasoning, the specific act, and the intent the found in step, so the police can verify it. So this was the process workflow of our entire project.
ठीक है, no issue. Yeah, you can leave.
Thank you for your presentation.
Thank you, sir.
Now, I would like to call upon Tentu Erlin Philip, sir, to present his paper.
Ma'am, am I audible?
Yes, you're audible, ma'am. You can start sharing.
Give me a second, please. Is my screen visible?
Yes.
Yes, okay.
Start your presentation directly.
Very good afternoon to everyone. I'm Tintu. I'm pleased to present our paper titled Multi-Model Crop Disease Detection for Smart Agriculture Using Deep Learning and IoT Data. It's a collaborative work from Ramdev Baba University, Nagpur. Our work focuses on improving crop disease detection by combining deep learning-based image analysis with IoT sensor data. It's by fusing a visual and environmental information through a reliability-weighted framework. We achieve higher accuracy and robustness than image-only based models, demonstrating the potential of multi-model approaches for smart agriculture. So the motivation of this was agriculture, like crop diseases are a major challenge in agriculture, and it causes clearly about 20 to 40% yield loss every year. So it is a key pillar of global food security, and there are many disease detection techniques or identification, but still many factors are apart. So traditional disease detection or identification relies on manual field inspections, which are time consuming and impractical for large scale farming. The farmers or experts, they visually inspect the crop, and it is very slow and it's very subjective. And with the coming of computer vision and deep learning, particularly CNN based models, they have enabled automated disease detection from leaf images with high accuracy. However, image based models, they only approach or work under controlled conditions, and they fail to generalize the real world agriculture environment. So for this, a proposed or the problem statement is the image based models, they work only under controlled conditions. However, in real farms, lighting, backing, weather conditions all vary. So the crop diseases are strongly influenced by environmental factors such as temperature, humidity, and rainfall, and these are not captured by vision models alone. So with the growth of IoT, Internet of Things in agriculture, environmental sensors enable continuous monitoring. These IoT sensors, they capture this critical environmental factors such as temperature, humidity, rainfall that influence disease progression, but they produce unreliable results due to noise, delays, and lack of visual confirmation. So this is a challenge, and this motivates the need for a multi-model approach that combines visual and environmental data for robust crop disease detection. So our proposed solution is to address these issues, we propose a multi-model crop disease detection framework. The framework combines deep visual features from leaf images with environmental features from IoT sensor data, such as temperature, humidity, and rainfall, using an attention-based fusion approach. To overcome the lack of paired image sensor samples, we are using class-wise condition sensor prototypes and during training to guide the model multi-model learning. And a sensor reliability aware evaluation strategy is introduced to handle the noisy or partially corrupted sensors. Now the data set. We used plant village data set from Kaggle, and the experiments were conducted on tomato, potato, and pepper crops. Each crop, it contained multiple diseases categories along with healthy samples. And images was resized to 224 by 224 pixels and augmented to improve generalization. So this was a data set that we used. This shows the top row. We used 3 crops, and you can see the images over here. Their classification is not easy because they all look similar. So overall, the figure highlights the visual diversity of disease symptoms across crops, such as spots, discoloration, curling, and texture changes, as well as healthy leaf appearance as well. So this images serves as visual input modality for training and evaluating the proposed cross disease detection models. So the methodology is uh, the convolutional neural network, CNN, is used to extract the visual features from leaf images. And for environmental features we include temperature, humidity, and rainfall. These two modalities are fused using a reliability weighted fusion mechanism, which controls the contribution of the sensor data. So how did we train it? We actually, for our experiments, the data set was divided into 70% for training and 30% for testing. The proposed model was trained independently for three different crop categories: tomato, potato, and pepper, using the same fixed training configuration. We trained the model for only 3 epochs, like very small training time with a batch size of 32, using Adam optimizer and learning rate of 3 into 10 power minus 4. The training duration was intentionally kept short to evaluate whether the model was working properly without extensive fine tuning, which reflects the realistic deployment constraints in real world agriculture sensors. And finally, the model performance was evaluated using accuracy and F1 score metrics. We only used 2 parameters over here. So this was the performance results for evaluating. We used accuracy and F1 score as mentioned earlier. Accuracy measures the overall correctness of classification, whereas F1 score helps in analyzing the effect of class imbalance, which is common in agriculture data sets. So in the table, the proposed multimodal fusion, it gives strong performance on tomato and potato data sets with 96.17 percentage accuracy for tomato and 97.68 percentage accuracy for potato, along with high F1 scores. So this results demonstrates the effectiveness of combining visual features with sensor-driven data. But here for pepper dataset, we observe a comparatively lower performance because we didn't have much. We had a very smaller dataset size, and training samples were very less. Despite this, the model still maintains a consistent behavior without overfitting. So overall, this indicates that the multimodal fusion outperforms image-only approaches and provide improved robustness for real-world crop detection. Other than this, further analysis like a class-wise behavior, a reference confusion matrix was generated for the tomato dataset because that dataset we had a lot of confusion. It was very hard to classify this. So this figure, it shows a confusion matrix for tomato datasets using our proposed multimodal fusion. We observe the strong diagonal dominance, indicating that the majority of the samples are classified correctly in their respective disease categories. Classes like some diseases like tomato yellow leaf curls and healthy tomato, they achieve near perfect accuracy, but there were minor misclassifications between visually similar diseases like bacterial spot or leaf spot, which was expected. So overall, the false positives and negatives are limited, confirming the robustness and real-world applicability of our approach. Now, we did a comparison with the CNN model. So to validate the proposed strategy, the contribution of multimodal and the proposed model was compared against an image only CNN baseline, which was trained and evaluated using the same tomato dataset with the same train and test split of 70 to 30% and the same evaluation training environment. So here the CNN achieved lower accuracy and F1 score, showing visual information alone is insufficient. So by integrating environmental factors like temperature, rainfall, and humidity, the fusion model improves performance and maintains balanced classification across all disease classes, demonstrating the importance of multi-model learning for effective crop disease detection. So in conclusion, our multimodal fusion framework significantly improves crop disease detection accuracy across different crops, including tomato and potato. It handles sensor uncertainty effectively. It converges quickly with limited training and requires minimal computational resources. Compared to the image-only CNN, our approach is more stable, efficient, and adaptable, addressing limitations of vision-only methods by explicitly incorporating environmental and sensor data. So this research highlights its practical applicability for smart future. And looking ahead, we plan to integrate real-time field sensor data, expand the framework to more crops and diseases types, and deploy the model on edge devices or mobile platforms. Additionally, analyzing temporal sensor data could further enhance the prediction accuracy. So this is all, and these are the references papers. Thank you.
Yes, open your workflow.
Yes, sir.
Workflow.
Yes, sir.
Okay. Where is your system architecture?
Sir, shall I open my paper, sir?
Yeah.
Paper we have not like system proper architecture is not, sir. This is what we did, sir. This is our proposed work. We trained the crops. First, we did a tomato training analysis. 3 crops were taken, sir, and then we did an analysis for each, like tomato, potato, and all. And we tried to one second, sir, one second, please. The analysis, and we worked for a training log. So we used for epoch, there was a training logs for tomato from 1 to 0.58 loss. It dropped very, the loss was dropped very fast. For potato also, there was a training loss of 0.40. So we trained the model, sir, over here for each crop, sir, over here. And then the performance was taken like this, sir. We calculated the accuracy using the two positives, and
You have used only the 2 parameters for evaluation matrix.
Yes, sir. Accuracy and F1. We did only 2, sir.
Okay. But you can be use the multiple parameters also,
Yes,
na?
sir. Yes, sir. We'll surely look into it, sir, and we'll create more. So just for now, we just wanted to see if it was better or not, sir. That's why.
Okay. So which modalities you have used here?
CNN model, sir.
Modalities. Because your title is multimodal, na?
So one was we use the CNN model along with the sensor data, sir. The IoT sensor data. So the raw sensor data were it was normalized. So we just converted into feature vectors, and then we use the class-wise prototype for that. So the class-wise prototype, it usually helps us to get an average of the model, no, sir. So we just did like that, sir.
Okay. And which method you have used for the features extraction?
In we used, sir, for deep feature attention-based fusion approach we took, sir.
Okay. But you can be use the multiple parameters for comparison pattern.
Okay, sir. Thank you so much, sir. Thank you. Thank you for the time. Thank you, sir.
Yes. Yes, you can leave.
Thank you, sir.
Yes, ma'am. Any other presentation remaining?
There are no more presentations, sir. Now I would like to move towards the closing remarks.
Yeah.
Now all the presentations are done. I sincerely thank all our authors for their excellent presentations and contributions in this session. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. And we are hoping to have you in the 11th version next year as well. All the presenters would be getting their digital certificates through mail within 2 days, and the publications are going to be live within 7 to 8 months, and kindly cooperate with the team of SMARTCOM. Next, I would like to thank our session chair.
Thank you.
Just a second.
I think all presenters have the good technology, recent technologies used in their research work. So they can be some remark. So as per their remark, they can be modified their paper and submitted.
Yes, sir. I would like to thank you, Dr. Ganesh Jadhav, sir, as well as Dr. Ramesh Punya, sir, for chairing this session. Here is a token of appreciation to both the chairs on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, sir.
Yes, yes. Thank you.
Yes,
Thank
sir.
you for giving me opportunity to as a session chair. Thank
Yes,
you.
sir.
Thank you.
Yes, sir. Thank
Yeah.
you for your valuable presence.
Yes. Yes.
Before finally ending this session, I would kindly request you all to switch on a camera for a quick snapshot of the session. Can you all switch on your cameras? Yes, the snapshot is done. Now we can finally end the session. You all can leave the meet and stay safe and healthy. Thank you. Thank you for attending.
Thank you.